thank you everybody for coming. Just to, it's probably the busy week, but anyway, so we're going to talk about Dockerizing your rShiny app. So I hope that you guys know a little bit about Docker, about rShiny. If you don't, then it's great that you're here. Okay, but I'll put out a disclaimer. I do not work for Docker, nor do I work for rShiny, so I am not an expert, but I do know a little bit of this here and there. Okay, so basically let's start off with what is Docker. It is basically a container, so it works somewhat like your virtual machine, but it's not. We'll talk about the advantages over virtual machine after this. Okay, what it does, it wraps the entirety of a software. So let's just say you have a few line of codes and you install several things on it. So this thing will wrap everything in it, and then it just ships off as an image. And then when someone downloads your image and then run it, they have everything that you have already developed. Right? So anything that can be installed in a server, it can be done. It wraps anything. Right? Why Docker? It's lightweight because it shares the same OS kernel, unlike virtual machine where after you install the virtual machine, then you have to install the OS on top of it, then slowly install other stuff. So it shares the same kernel. It starts instantly and it uses less RAM compared to a virtual machine. Okay, it's open. It's based on open standards, and it's secured by default because it isolates the application from another application by itself, and it also isolates application from the infrastructure. Right, that's the basis of containers. Okay, virtual machines versus containers. This is just ripped off from Docker itself. So basically, the basic idea of this is virtual machine, you have to install it and then you install OS and then you install the other software on top of it. But for Docker, it wraps everything. Everything is installed in that image itself. So you have your, let's just say Ubuntu is installed into it, your rShiny is installed into it. Everything is inside the Docker image. So once you just run it, everything is installed. Right? So for you to use Docker in your machine, if you're using Windows or Mac, you will, okay, wait, I'll not jump into that first. Why Dockerize your rShiny app? Because we want to make our rShiny app available. So before this, there's two options. We have the Shiny server or platform as a service. Platform as a software, shinyapps.io. This thing will probably require you to pay quite a fee to use it, or another way is you just want to send your server.r or your UI.r file doc to someone else, but that might be too difficult, too technical for the layman. So when you have a Docker image, you just tell them, oh, you can just use Docker and then run the image, which I will show you later on. Right? Anyway, so what do you need to run Docker? You probably need Docker Toolbox for Windows and Mac. For Mac users, you can just get it from here. Or for Linux, you just download the Docker itself because it runs on the Unix platform. Yeah. So everything is kind of, you need to have a little bit of idea of bash and everything. Okay. So to set up a Shiny server, okay, it's simple. You just use this. Once you have installed your Docker Toolbox and everything, you just run this on your terminal. Docker run --rm--p. So you're actually using the port 3838 from your local host. And Rocker /Shiny is just setting up a Shiny server. Okay. And if you want to run other Shiny apps, you will edit the Docker file. The Docker file, we'll look into that later. Okay. So let's just look at an example of a Dockerized rShiny app. Okay. So here, it's just a simple run of this command. So you're exposing a port in your localhost. here is the R Shiny app that was is developed by Flavio Barros. So we're just using an example of it. So it's a word cloud from, see, it works just like the normal R Shiny app. You can choose, you can change. So so let's go down to how it actually works. Okay? You'll actually you have these few files, which Docker file is mainly like your recipe for creating your image, right? So when you look into it, I hope it shows up here. Oh, it's showing up there. Okay, so the first part is where from basically you're just getting an image. So R base is actually developed by R Shiny. It already has the Ubuntu in it. So to create R images, you can use images upon images. So for this from, you're actually getting an image that was created by RStudio, which is R base, which has Ubuntu and Shiny in it already. Actually, they have Ubuntu in it. So if you look at all this, these are basic bash codes. Yeah, apt update and all this. Right? It's basically running Ubuntu in itself. Sorry. Then you want to install R Shiny, and then after that, you just like your R Studio, you install your packages. So you have run R, install all your packages, and you then get it from your repository. And then these are just normal things that you can just copy paste from Rocker Shiny. Right, this Shiny server called expose AP. So this is the basic of a Docker file. If I were to put it in analogy, it's basically your recipe for creating it, for creating the image. Right. Then you put your server .r and UI.r in a folder called my apps here, or oops, sorry. Where do I see it? Sorry. Okay, yeah. So it's back into this folder, which you can actually rename it anything you want, as long as in your Docker file you are referencing it here. So it could be like, you want to do a map, you do Shiny map, and then the folder itself has the name Shiny map as well. So that is how you Dockerize your R Shiny. Of course, then it's in your server.r and your UI.r files, it is the same file that you run in your RStudio. Right. So this is a basic idea. There are some difficulties in Dockerizing your R, no doubt about that. Firstly, at this point, you need to know what packages you need. Because if, let's just say you want to install rgdal packages, you need to have you need to apt get libgdal -development. So those you need to know. So if you just a matter of just running it, you may not actually get what you want. So you need to go down and really know what packages you need. So it is a bit technical, but on the end user side, when you have developed the image and you then pass it on to someone, it's as simple as just now we've done docker run -rmp expose the port, and then the name of your image. So this is creating your images locally. Okay. But once you want to send out your images, you have to host it on Docker Hub and all those, or DigitalOcean. But that will be left to another session by itself. So I think that's the end. That's the end of my presentation. So I would say Docker is fun. To create the Docker file itself is fun because you need to know what you want, and it allows you to have full control of what happens in your image. And if you don't release your Docker file, people won't know what is in it. Okay, so let's just say you want to release your RShiny app that contains a lot of data, but you don't want people to actually go in and mess up with your source and everything. So you can just give them a image and they download, and then they can just run it on locally in their machine. Yeah. For example, like for a custodian for my research, they would like to see the RShiny app that was run locally on my machine, but I wouldn't be wanting to give them the whole source code. So I'll just give them a Docker image and they can run it on their own. Yeah. Is there any questions?
So by packaging it as a Docker, right?
Mm-hmm.
There's no way for anyone to get hold of the UI.R.
You can put it on GitHub. You can put your Docker file, everything, like the whole. Let me see whether I can. So this guy, he put all this on GitHub. So
Okay.
yeah, you can just download it from GitHub. You just clone it.
Docker file.
Yeah. Docker file is like your recipe. So this whole shiny dash word cloud dash master was downloaded from GitHub. So you can give up.
What's the content of my app?
My app is your server.r and your UI.r.
So
Yeah.
you
You can give it out. But let's just say I don't download this. I just
don't want to.
You can just put it on your image as an image. Just upload your image.
Oh, okay. So everything is encapsulated in your image. Okay. How about performance issue? We all know that with a VM you can specify the resources for that particular VM. So for a Docker, your recipe will specify the resources allocated to that Docker instance. Is that right?
I'm not too sure about that, but I'm pretty sure if you go Google it up, I'm sure that you can somehow tweak whatever performances you want on Docker. I'm not really too sure about that.
Okay.
I'm sure that it will make someone's life easier. Once you get used to it, once you are so used to creating Docker images, then it will be easy. Maybe the first few rounds of trying it might be hard. As I mentioned, the difficulties will be knowing what your packages are and even getting the correct things out. Yeah. But once you get used to it, once you're so used to it, it's just as simple as that. And even as a user, Docker. You can go Docker Hub and you can find whatever Docker images that you want. There's Ubuntu, there's Node.js, there's Nginx, Nginx. Yeah, Nginx. So those things they have both official and also those that are done by developers themselves. Yeah. So official being like, let's just say RStudio, they create their own Docker image. Yeah. So maybe for myself it won't be considered official. I just post it up. That can be used by other people.
So this, okay. What are the prerequisites for running a Docker image?
A Docker you just need the Docker tool, and of course there's something about Hyper-VM as well. Yeah, Hyper-V.
So it can be deployed on a normal workstation. I don't have to run it on a server.
You don't need to run it on the server.
And it's cross-platform.
Yeah, you have like Mac OS and everything. Because this Docker image, it's this same Docker image can be run on Mac, Windows or Linux. I'm not too sure if that's your question or you're talking about Docker itself. Is it runnable on different platforms?
Talking about the host machine.
The host machine can be anything. And even your image, if you develop it in Windows, you just run it on Mac, you can still run it because that thing internally has everything, right? That image itself.
Then I know there's such a thing called the Docker marketplace or something.
Yeah. So Docker marketplace or PC version, you can call it kinematic. Basically,
Kinematic.
yeah,
right.
kinematic is basically an app store like for images. So instead of needing to go to Docker Hub and then search through, it's some
And
sort
that
of,
one is open for use
Yes.
for anyone.
Yep.
So we can use that to maintain versions of our Docker app.
I've actually not played with kinematic that much. Yeah, so I do know, but all I know is some sort like your app store for Docker images. So you can go and look around.
Okay.
And of course, once you update your image as well, you can put versioning as well, but usually people will put latest and all. If you don't have your version tag, they'll just put it as latest.
Nice.
Yeah.
Any downside to this?
Any downside to this would be if you do not have your images already. Let's just say in my image I want to have Ubuntu Node.js and Nginx, okay, and I do not have those images in my computer. Okay, it runs through the whole downloading of the images and all. But if you already have run it before, the images they will just check back. Oh, you have this image, then the process will be faster to run that machine. So let's just say the word cloud that I showed just now. If I've not run it before, it'll probably take about, since it's small, probably take about 5 minutes or 3 minutes to run it because it downloads everything. But then if I have the image already, it's just as instant as clicking on a exe file. No.
Yes.
Yeah.
Right. Any question from the audience members? You look like you have something to ask.
There's one thing called like a Docker data center. Have you heard about it?
I've read about it, but I've not gone into much about it. Yeah. Is it something like it's, if I'm not mistaken, it's a very big scale, like for, let's just say you want to maintain an image and something like that, right?
Something that joins between.
Yeah, it's several.
workstations,
Yeah. So that if I'm not mistaken, if you run the image on one, it like sets on the other machines as well.
So few clusters can run the same
Yeah.
Docker image at the same time.
So if you update one, then you don't need to individually to on all machines to update it.
Anything else from the rest? No? Okay, very much. Thank you very much, Jeremy, for enlightening the talk. And we are done.